Okay. I'm hoping to get all of this done in one take. We'll see what happens. I'm not sure how long it's going to last. That's why it's done like this. You need to let me know which one you like better. Would you rather it be like this, or would you rather it be the way it was before? Do you like seeing the whole screen, the whole board, even though I don't use the whole board? Or would you rather just see the part that you know I'm going to use? I mean, I can't always do it that way, but I could go back and do a lot of them that way, I think. I don't know. We'll find out later. This is what we're doing today, solving equations. Now, I know you're thinking, we did solving equations already. Yep, but now we have a new tool called factoring, and we have to figure out how that fits in with the whole solving equations stuff. So that's what today is. So before we ever get to this part over here, we're going to talk about this over here. Now, I know you're thinking to yourself, gosh, that seems pretty simple. A times B equals 0. Can't get much more complicated. Well, here's my question. If I were to tell you that A was a number like 2, you would have to tell me that B was what number? That's right, B has to be 0. So since B has to be 0 if A is 2, because 2 times 0 is 0. But if I were to tell you that B were 2, then you'd tell me that A would have to be 0, because one of them has to be 0. That's a rule. One of these has to be 0 in order for that to be 0. It's just a rule, the way things are. So let me ask you this. If I were to have x plus 1 times x plus 5 equals 0, and I told you that this parentheses was really 4, you tell me that that whole parentheses then must be 0, because one of them has to be 0. That's what we just said. One of them has to be 0. So since that's the case, I can say, well, since we know one of these has to be 0, then that means either x plus 1 is going to be 0 or x plus 5 is going to be 0. Now, we don't know which one it is, but it has to be one of those two. And since that's the case, then I could go ahead and solve this and say x must be -1 or x must be -5. And that's kind of the stuff we're going to get around to today. So back when we solved equations before, we used this procedure. Ta-da! I know it's great, right? So back when we used this procedure, you remember you had to draw the line underneath the equal sign, you had to simplify both sides, you had to get rid of the parentheses, get rid of the fractions, combine like terms. Wait a minute, what's all this? This is step D. Step D is here because now we can have an exponent. And if we have an exponent, that means we have to get everything on one side equal to 0. Having everything on one side equal to 0 is what allows us to use this trick we got right here. If we don't have that, we can't use the trick. Can't use the trick, there's no way you're going to solve it. So you got to make sure you get everything on one side equal to 0. Once you get everything on one side equal to 0, then you can do the Factoring 101 chart. Yeah, that's right. The whole entire chart fits in this one little spot. That's why you had to memorize it. And then you have to set each factor equal to 0 and solve each like below, which I did there. I set each factor equal to 0 and I solved them out. So let's do a couple. C squared plus 8c plus 16 equals 0. Supposed to draw my line. Supposed to simplify both sides. They're as simple as they can get. because we don't have any parentheses, don't have any fractions, don't have any like terms. Now, because I have a square term, that means I have an exponent. Because I have an exponent, that means I need to follow this. If there were no exponent, then we go back just the way we were. Skip D. But since there's an exponent, I need to get everything on one side equal to 0. Well, it's already got everything on one side equal to 0. So we're good. Then I need to do the factoring 101 chart. On this side, I'm guessing, because you can't really do it to a 0. So on this side, let's see. Is there a greatest common factor? No. How many terms do we have? 3. What's the leading coefficient? 1. Which means follow the rules. 2 things multiply together to give me c squared is c and c. 2 things multiply together to give me 16 and add to give me 8, 4, 4. Plus the back means the same for the sign's the same as the one in the front. So now I have this is equal to 0. And now that I have that, according to what we just talked about, that means that either this has to equal 0 or that has to equal 0. So I set each and every factor equal to 0. So everything that's got a little multiplication going on, that's what gets set equal to 0. So that means this c plus 4 has to equal 0 from there, or this c plus 4, oops, that is not a plus, has to equal 0. Then I solve each just like we were solving a regular equation. So I took what was a square and split it up into 2 separate equations that I could solve because there are no more exponents. So I go minus 4 and minus 4, minus 4 and minus 4. In this case, that means c is equal to -4 or c is equal to -4. So c must be equal to -4 because those are the only options we got. We have solved it. Look at another one. Supposed to draw a line. Simplify both sides, get rid of the parentheses, we ain't got no parentheses. Get rid of the fractions, we ain't got no fractions. Combine like terms, we ain't even got them. Is there an exponent? Yes. So I need to get everything on one side equal to 0. The question is, do I want it all on this side or do I want it all on that side? Well, you know how this side is positive, this w square is positive? You always want your square term to be positive. So you put it on whatever side is going to make that square term positive. It's got to be positive because we never did factoring where the square term was negative. So we need the square term to be positive. So I'm going to go ahead and say, since this is already positive, let's move that over on this side. So I'm going to subtract 12 from both sides so I can get everything on one side equal to 0. Can't combine the 12 and that because they're not like terms. But now I have everything on one side equal to 0. Now I'm supposed to do the factoring 101 chart. Is there a GCF? No. What's the leading coefficient? 3. That ain't 1. 2 things to multiply together to give you 3w squared. 3w and w. 2 things to multiply together to give you 12. I'm feeling 4 and 3. So I'm going to put in 4 and 3. And then they have to be different signs. One of them's got to be plus, one of them's got to be a minus. I'm just going to put in a plus and a minus. I don't know which one goes with which. I haven't checked it yet. So that gives me a positive 4W and a negative 9W. That doesn't give me a positive, that gives me a negative. So let's go back and make this one a minus and that one a plus. That makes it right. Now that I have this, I can erase this because it was just where I checked. And I have that this is equal to 0 because it was my answer. And now I'm supposed to set each factor equal to 0. So now I say 3W minus 4 is equal to 0, or W plus 3 is equal to 0. Well, if I'm solving this one over here, I have to add 4 to both sides. Gives me 3W equals 4. Divide both sides by 3. So W equals 4 over 3. Or I subtract 3 from both sides and get W equals negative 3. Both of these are my answer. So both of them need to be boxed. So when it's not already equal to 0, you have to make it equal to 0. Let's look at another one. X minus 4 times 3x plus 2. This one's a little different. Draw the line, simplify both sides, get rid of parentheses, get rid of fractions, combine like terms. It's a lot of stuff I could do to this one. And if I were to get rid of my parentheses, that means I'd be multiplying these two out, which is going to give me a square term. And when I get that square term, I'm going to have to turn around and factor it back out. And when I factor it back out, it's going to be right back here. So I'm not going to go through all the trouble of multiplying this back out if I don't need to. There's only one time when you really need to, because they're trying to help you out, because they went ahead and factored it for you, saved you some trouble. But sometimes it's not them saving you trouble. Sometimes it's them creating trouble for you. You have to know the difference. So I don't need to go through and multiply this all out because I already have my 0 there. If that hadn't been a 0, I'd have to go ahead and multiply it out, combine like terms, move stuff from one side to the other, get everything equal to 0, then factor. But they've already got a 0 there. And since everything's already equal to 0, it's just like I'm picking up in the middle of my chart. In the whole middle of the process. They've done half the process for me. I don't want to go through and do it all over again. That's just more work. So since I know that these two things are multiplied together to equal 0, then I know that x minus 4 must equal 0, or 3x plus 2 has to equal 0. So x is equal to 4. Or 3x is equal to negative 2 divided by 3. X is equal to negative 2 over 3. Don't use decimals for this stuff. Unless they give you decimals, don't use decimals. Leave them as fractions. Try not to change them to mixed numbers. Just leave them as improper fractions. Where in algebra we like improper fractions. Okay. Let's look at a harder one. Oops, it's a Z. Go ahead, try it. Let's see what happens. Okay. So draw my line. No parentheses, no fractions, no like terms. I need to factor it. So I'm going to take out a 3z because that's my GCF. And that leaves me with z minus 2 is equal to 0. Then I'm supposed to set each factor equal to 0. Well, that means anything that is multiplied ends up having to equal 0. Well, this says 3 times z minus 2. So I'd have to say 3 is equal to 0, z is equal to 0, or z minus 2 is equal to 0. Got 3 different options. Can 3 ever be equal to 0? No, it doesn't happen. So since it doesn't happen, then we know that this isn't going to be one of our answers, because that could never happen. Can z equal 0? Yes. That one can work. And then z minus 2 can equal 0 if z is actually 2. Anytime you have a square term, you should end up with 2 answers and only 2 answers. Does that mean if you have a cube there, you should end up with 3 answers? Absolutely. If you have a 4 for an exponent, you end up with 4 answers. All that's true. One more. Pause the tape. Let's see if you can do it by yourself. Okay. Draw my line. And gotten rid of my parentheses, ain't got no fractions, combined like terms, ain't got none of them. If there's an exponent, get everything on one side equal to 0. I'm going to move my 6 because I want to keep that positive. So minus 6 and minus 6. That makes it 5m squared minus 7m minus 6 is equal to 0. Now I've got a factor. 5 is my leading coefficient. I'm going to say 3 and 2. And because I already know, because I'm fast like that in my head, it goes like that. gives you a positive 3m and a negative 10m, which is how you get your negative 6m. Then I set each of these equal to 0. So I subtract 3 from both sides. 5m equals negative 3. Divide by 5, m equals negative 3 over 5. Or I add 2 to both sides and get m is equal to 2. Now, here's the thing. When it comes to your test, and you have to check these because you want to make sure they're right before you turn in your test, that means you're going to have to take these numbers and plug them in place of that m and see if you get the right answer. That's not always easy when you have fractions. So you either need to bone up on the fractions or you need to make sure you're being very careful about this. Now, if we were to go back and check, which I'll do in this color, you'll see that we have to plug it into the very original problem. So that would give me 5 times negative 3 over 5 times negative 3 over 5, because it's squared, gives me a positive 9 over 25 minus 7 times negative 3 over 5. And we want to know if that equals 6 or not. Here, this 5 cancels out with that 25, leaving me with a 5. So that's 9 over 5. And then that's going to be plus, because a negative times a negative is a positive, 21 over 5 equals, and if I wanted to change 6 to have a denominator of 5, that would be 30 over 5. And 9 plus 21 does give you 30. So it does work. That one does check out. Going back and checking with the 2, I would get 5 times 4, because that's what 2 squared is, minus 7 times 2 is equal to 6. So 20 minus 14 is equal to 6. Well, that's true. So the 2 must be good too. Are they always going to check out? Yes. For you right now, they will always check out. I would not suggest using this method to check your work unless you were taking a quiz or a test. Otherwise, I'd look at the back of the book. I would ask me. I would I'd look in the back of the book or ask me, because that's faster than this. But I wanted you to see this done once, so when you got to your test, you'd be able to do it if you really felt like you needed to. Now, there's one more thing we need to talk about with this. This whole process is because we were solving equations. It's not going to tell you to solve equations unless there is an equal sign in the problem. If you don't have an equal sign in the problem, they're not asking you to solve the equation. Don't try to do too much. So when you look at the problem, you have to see, are they asking me to factor? If they are, you just do the factoring 101 sheet. It's when they're asking you to solve the equation that you do all of this stuff. The only way to know is to, number 1, read the directions, and number 2, look for the equal sign. Because when you're doing factoring, they won't just put an equal sign in there. You hadn't seen an equal sign all chapter long. Today's the first day we've had one in there. So there's a difference between factoring, which is just this factoring 101, and between doing all the solving. A lot of people, for some reason, find all the solving somewhat comforting and easy, and they don't understand why that's so easy when this one step was so difficult for them. But it's because we went through all the difficult stuff in that one step that makes all of this easy. You've been doing this forever. So it feels good to get something so simple. Homework, classwork. And today is the last day you'll do your classwork with me. I'll tell you why in a minute. Classwork, page 307. Numbers 1, 11, 1 comma 11, 21 and 31. And then the homework is 5, 15, 25, and 35. That's what you're doing today. Tomorrow, I want you to go back to section 7.8 because we never got to do that one. We skipped that one. Section 7.8 is just all factoring. None of it's solving equations, it's just factoring. And it's all the factoring you've done before. So it can be anything within that factoring 101 chart. So when you do section 7.8, you're going to be doing numbers 1 through 25 odd. There is no video to go with 7.8 because you've learned it all in the Factoring 101 chart. Your mom, however, does have a copy of the Factoring 101 chart. You were supposed to have already printed it off in the email that I sent you. But if you don't have that, you can print it off and use that for this and for section 7.9. You cannot use it for your test. You have to know about your test. So make sure you have memorized that for your test. Make sure you are good with factoring from 7.8. Make sure you are good with this from 7.9. And on your test, I think I knocked it down to a total of 20 questions. And I'm telling you now, one of them, the answer is prime. But only one of them has an answer of prime. So you need to make sure that you time yourself correctly, because I don't want you to spend a ton of time on one problem and then waste all your time on other ones. If you find out it's taking you too long to solve a problem, skip it and come back to it later. Because your mom is going to time you. You get a definite hour, no more, for 20 questions. So that means you got to be doing a question every 3 minutes. So you can't be wasting time on stuff. And some of these questions take 3 minutes. So you better be careful. But hopefully it'll all come to you really quickly. Anyway, we'll see what happens. I'll talk to you in a few minutes. Okay.